Hey all, thanks for being here. My name is Jimmy Katiyar and I am a senior manager at SiriusXM USA. Today I'll be talking about building scalable MLOps pipelines for enterprise systems. This topic is critical because most machine learning projects don't fail due to poor models. They fail when trying to scale them in production. I'll share how at SiriusXM we build systems that can support millions of daily transactions reliably. The aim is to provide you with a mix of theory and practical insights that you can apply in your own organizations. Here's our agenda. We'll begin with the challenges enterprise face in deploying ML. I'll show you why traditional IT deployment approaches break down when applied to machine learning. Next, we'll dive into the architecture fundamentals. These are the building blocks that every production ready ML systems need. Then I'll explain the implementation framework, a step-by-step way to automate and streamline deployments. After that, I'll share some real-world impact metrics from SiriusXM so you can see the measurable benefits. Finally, closing with a strategic roadmap so you know how to bring these practices into your own organization incrementally. Now let's talk about the enterprise ML challenge. Many organizations still rely on manual processes. Deployments are done by hand, environments don't match between development and production, and teams work in silos. As a result, the deployments can take months, incidents occur frequently, and compliance is difficult. This isn't just a technical issue, it's a business one. When it takes 60 to 90 days to put a model into production, you lose agility. Competitors can iterate faster with and will outperform you. So the gap between data science experimentation and production requirements become a major obstacle. Here we see the MLOps maturity journey. At level 0, things are completely manual. Deployments are ad hoc and monitoring is almost non-existent. Level 1 introduces some partial automation, maybe a few scripts or a basic CI/CD setup. At level 2, you can start continuously delivering models with pipelines and some monitoring. Finally, at level 3, everything is automated. You have self-healing systems and robust monitoring in place. At SiriusXM, we went from level 1 to level 3 in just 18 months. That shift reduced deployment times from weeks to hours, while ensuring stability for millions of daily transactions. These are the four pillars of MLOps architecture. First, automated model validation ensures only high quality, compliant models get deployed. Second, CI/CD pipelines standardize deployments and make rollbacks easy. Third, monitoring systems keep track of model performance, data drift, and overall system health. Finally, scalable infrastructure such as Kubernetes allows us to manage workloads dynamically. Together, these pillars are what make scaling to hundreds of production models possible. At SiriusXM, we built an automated validation framework to ensure that only production-ready models make it live. This framework ensures models on three dimensions: statistical performance, operational readiness, and compliance. Statistical checks cover accuracy, precision, recall, F1 score, and business KPIs. Operational readiness checks latency, scalability, and throughput. Compliance ensures explainability, bias detection, and regulatory alignment. By putting these gates in place, we reduce production issues by 94%. That's a massive improvement in reliability. This diagram illustrates our CI/CD pipeline. It starts with version control, not just for code but also for datasets, configurations, and artifacts. The build and test stage uses containerization, performance benchmarks, and security scanning. Staging is where we do shadow deployments and A/B testing to ensure the model behaves correctly under load. Finally, in production, we rely on canary deployments, automated rollbacks, and audit logs. The result? We brought deployment times down from 45 days to just 4 hours. That's the power of automation and standardization. Monitoring is essential because models degrade over time. We monitor across four dimensions: model performance, data quality, system operations, and business impact. That means looking at accuracy and KPIs, checking for data drift, watching latency and errors, and finally measuring revenue or conversion impact. In the first year alone, our monitoring system detected 28 critical drift incidents before they could affect customers. This kind of proactive monitoring helps prevent costly business disruptions. Enterprise ML workloads are unpredictable, so infrastructure has to be both powerful and flexible. We use Kubernetes for container orchestration and autoscaling, Apache Spark for distributed data processing, and load balanced inference services for redundancy. Security is equally important. We enforce strict access controls, encryption, and audit logging. As a result, our system now handles 3.5 million inference requests daily with 99.99% uptime and sub 50 millisecond latency. That's production grade infrastructure at scale. Of course, technology alone doesn't solve everything. Organizations face challenges like mismatched skill sets, fragmented tools, and inconsistent success metrics. Often, engineers and data scientists simply don't speak the same language. The solution we found at SiriusXM was to unify development environments, standardize workflows, and create shared KPIs. Cross functional collaboration was key. In fact, our VP of AI engineering said the biggest win wasn't technical, it was getting both sides to speak the same language. This chart compares metrics before and after MLOps. Before, deployments were slow, expensive, and error prone. After implementing MLOps, deployment timelines dropped dramatically. Incidents were fewer, iterations became easier, and costs went down. The takeaway is that MLOps isn't just about engineering, it directly translates into business efficiency and agility. Here's the roadmap we recommend for implementing MLOps. Phase 1 is about laying the foundation, standardized environments, version control, and basic pipelines. Phase 2 introduces automation with CI/CD pipelines, validation, dashboards, model registry, and metadata tracking. Phase 3 scales the system with Kubernetes orchestration and advanced monitoring, along with data drift detection systems and establishing automated rollback mechanism. Finally, phase 4 focuses on optimization, implement advanced feature stores, self-healing infrastructure, feature stores, restraining, and governance. The key is not to attempt a full transformation overnight, but to deliver increment values in phases. Now let's look at common pitfalls. First, don't become tool obsessed. Tools should serve workflows, not the other way around. Second, don't underestimate the cultural change required. If teams don't adapt, the initiative will stall. And third, don't overcomplicate your first steps. Start small, prove value, and then scale. The most successful implementations start with a single high value use case and expand from there. To summarize, MLOps provides a real competitive edge. Organizations that do this well can deploy models 20 to 30 times faster than their peers. The four pillars, validation, pipeline, monitoring, and infrastructure, are your foundation. But equally important is bridging the cultural gap between teams. Finally, remember, start small, focus on value, and scale quickly once you have proven success. This approach will maximize both technical and business outcomes from your ML investments. That brings us to the end of the session. I hope you are walking away with not just theoretical knowledge, but also practical steps for building scalable MLOps pipelines. Thank you so much for your time and attention, and have a great rest of your day.